Welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the Microchip Is podcast. Today, I'm joined by Wayne Liang, who's the Automotive Segment Sales Manager at Microchip, and he's going to tell me why Microchip is e-mobility. Welcome to the podcast, Wayne. It's great to have you on. Can you tell me a little bit about you and your role at Microchip?
Thank you for having me. I'm the Automotive Segment Sales Manager at Microchip, and I lead the e-mobility effort. My role focusing on connecting with our customers in electric vehicle industry, including cars, trucks, bus, chargers, and two-wheelers. It's all about understanding what they need and staying ahead of the trend. I work closely with our global sales team to see what's happening in the market, like the changes in technology and shift in demands. Once we understanding all these trends, I work closely with our business unit to build solutions that are efficient, reliable, and adaptable. Our goal is to help our clients to stay competitive in this fast-paced market. It's a dynamic role, so I enjoy seeing how our solution help our customer gain more market share.
I mean, that sounds like a great role because you're in a market that's in a really exciting time. Electric cars, e-mobility is growing so fast. So, I mean, when you're talking to customers, what are the biggest trends you're talking to them about, and how are they changing the industry?
It's really an exciting time. There are a few major trends we are seeing today. First, there's a big push for faster design cycles. Companies, they want to get their EV, their chargers to market as quickly as possible to stay competitive, especially with a few players coming into the market. And then there will be efficiency is a big focus there because it impacts the range, the performance, and even cost. Another big trend is reliability. EV system needs to perform really well across a range of environments, from the deserts to freezing winters. The companies, they are putting more efforts in making this system that can last longer. And these trends are really reshaping the industry because they require adaptability and scalable solutions. Manufacturers, they need to be able to adjust this market demand quickly and deliver top qualities.
I mean, that sounds a real challenge. You've got, on the one hand, this demand for quality, reliability, efficiency. On the other hand, there's this pressure to bring more products to market more quickly. I mean, how are companies overcoming these seemingly contradictory challenges?
Absolutely. There are a lot of challenge out there, and there are a few of strategy that can really help in here. One of the biggest game changer is silicon carbide technology. Silicon carbide components, they are highly efficient and they can handle high voltage and heat really well, which is really crucial for EV applications. They allow companies to manage high power level while keeping heat to a minimum, which is especially important for fast charging system and high performance vehicle. Another helpful approach is modular design. It allows manufacturers to create flexible systems. A modular approach lets companies adjust components for different use case without starting from scratch every time. It's efficient because the same core design can be modified for entry-level EV or high-power models. We, Microchip, we offer many modular reference design to help companies to scale and adapt their products for wide range platforms. And finally, connect and secure features like remote diagnostic and over-the-air update are crucial. This type of connectivity allows companies to keep system updated. Let's say if a new software update can improve battery life or optimize power usage, company can roll out that remotely. It's a huge advantage to keep system performing at their best.
It sounds like there's a lot there, and I'm excited as an EV driver on the potential of software updates over the air, but also as an EV driver, a lot of it's about getting charged when you need to get charged, and I'd love to dive a bit into EV chargers. So, I've experienced that this infrastructure is expanding rapidly, but I'm interested in some of these trends I'm hearing about. I'm hearing about things like bidirectional charging and even, the vehicles kind of talking to the grid. Can you explain some of them to me as a non-technical person and, explain how these trends are affecting the development of EV chargers?
Absolutely. Bidirectional charging, especially V2G, just like what you just mentioned, is creating some exciting new opportunity for us and also for the industry. V2G technology allows EVs to actually send power back to the grid, which is a big help in stabilizing grids. Charger now can handle like those two-way energy flow, which means they require advanced power management and connectivity features. At Microchip, we design solutions that manage bidirectional flows, allow EVs to become more integrated into the energy ecosystem. So instead of just like drawing power, they can actually contribute to it.
I love that idea. So presumably, if there was a power outage, in theory, you could power your house from the car. Is that the idea?
That's exactly right.
That sounds cool. I mean, you know, the other thing that really interests me about charging is when you think about things like buses, these really large commercial EVs. I mean, that must be super difficult to charge the very large batteries there. So, what are the challenges in developing chargers that handle this kind of power level?
Yeah, so high power charging for commercial vehicle like buses that you just mentioned or trucks, it's definitely a challenging area. These charger needs to handle very high voltage and one reliability under heavy use. So safety, durability are critical here because of the high current involved, right? So think about a bus depot where multiple bus charging at once. That is a huge load on the infrastructure. It needs to be safe, reliable for continuous and long-term use. Another challenge is the environment that these chargers are in. And many commercial chargers are outdoor so that they have to withstand everything from rain, snow, dust, and intense sunlight. On top of that, the user interface needs to be simple and user-friendly so that it's easy for driver or fleet operator to use. Microchip high-power charger reference design are built with these needs in mind, focusing on safety, durability, and scalability so that commercial EV charging infrastructure, they can handle the demand of large fleet and the tough environments.
That's interesting. I mean, you talk about the high power charger reference design you've got. I mean, I'm just thinking about companies that are developing these chargers. Presumably, they've got to go all the way from like a low power home unit up to these huge commercial chargers. How are they doing it? Is there an approach to help them create solutions that are scalable, or do they have to design, separate systems for each level of power?
That's a really good question. Scalability is actually critical in EV charging system because the requirement, they are very different, just like what you just mentioned. From simple home setup to powerful commercial systems. Modular design and standard protocol, for example, like Open Charge Point Protocol, OCPP, are really helpful here. OCPP allows chargers to connect easily to networks, which is especially important in commercial setups where remote monitoring is key. Another approach is using a scalable architecture for the core components themselves. At Microchip, we offer a range of microcontrollers, MCU solutions from 8-bit all the way to 32-bit MCU and MPU, all share a consistent software architecture. And this allows manufacturers to develop software with the same tool across different platforms without have to rewrite the code. So for example, a company might use an 8-bit MCU in a basic home charger, then scale up to 32-bit MCU for high power commercial charger. Because they're working with the same software tool and architecture, they can reuse a lot of the codes. This would save a lot of development time and reduce the complexity. With the scalability requirement in mind, Microchip will build modular and flexible reference design, allowing companies to build a simple home charger to a complex multi-phase commercial system with the same base components. This combination of modular hardware and scalable software architecture make it easier for manufacturers to meet the diverse market needs while maintaining quality and functionality across their product range.
I love the way you say it makes it easy because it sounds like actually it's really complicated. You've got, high power requirements, scalability. It sounds really complex. I mean, one of the things you've mentioned is reference designs, but can you talk a little bit more about how a vendor like Microchip can actually support customers to make it easier for them to design chargers and actually help them achieve the demands of generating more products in less time?
Yeah, all these are definitely some challenges that our client facing, especially, the public charger, they have to handle a lot from extreme heat to freezing cold to rain and dust and dirt. So on top of that, they have to securely process payment. So user feels safe entering like sensitive information. So our rugged touch controller can solve these challenges by keeping the screen responsive, even if users are wearing like gloves. And it also includes secure PIN entries with encryptions, allowing user safety to enter payment detail right at the charger. This combination of durability and security helps the EV charger stay reliable in outdoor settings, protecting against elements and secure payment data. With this feature, public charging station can meet the demands both tough environment and today's high security standard for users' transactions. So to answer your questions in terms of high power and scalability, their needs vary so much from home charger to commercial chargers. One solution to use reference design is that we can offer strong foundation for building both high power and scalable solutions. And Microchip, for example, we offer reference design for a single phase AC chargers that is suitable for residential use to three-phase AC charger for commercial settings. And also we offer fast DC charging solutions like our 30 kilowatt power factor correction and DC to DC converter. So these solutions make it easier for company to build chargers that can scale up or down based on their applications.
That's really interesting. I mean, one of the things you mentioned was, AC and DC chargers, and obviously, if you've got an AC charger, you need an onboard charging system to handle that, and presumably they need to be fast and efficient in their charging as well. So, I mean, is that another exciting area where we're seeing a lot of advancements around onboard chargers?
Yes, you're absolutely right. The onboard charger market is actually evolving very quickly. And the market is actually demanding for faster and more efficient charging in a compact form factor. So that requires the onboard charger to convert power efficiently without taking up too much of space. So this charger also needs to be lightweight as well, since any load that added affect the overall vehicle efficiencies. What we have done is that we have developed the 11 kilowatts onboard charger reference design that are optimized to achieve high efficiency and stay compact. One area of advancement is the integration of high efficiency components, which can help reduce the energy loss during this power conversions. So every bit of efficiency gain helps the battery life and performance. In addition to power efficiencies, onboard chargers are being designed to be more adaptable as well, so that they can work across different EV models and charging speeds. So this flexibility is important as more type of EV entering the market and they have their own charging requirement.
That's really interesting because you're trying to get this charger into a really compact, efficient design. I mean, does that impact reliability? Are there strategies that are helping companies, make sure that the chargers are super reliable as well as being small and efficient?
Yeah, so company are looking for more smaller and more reliable designs, right? So compact, they have their own challenge as well, like you said. And because there's less space to work with. So every component has to be optimized. One key technology that helped the compact design is silicon carbide technology. It actually helped to improve efficiency while reducing heat, which is especially valuable in the tight space where cooling can be very challenged there. So high efficiency digital controller is also crucial because they can help manage power precisely, ensuring that each component they operate at the peak efficiencies. And at Microchip, we offer P-design hardware and software framework that help companies to streamline the development of compact, reliable onboard charger. So by providing these kind of structured designs, we allow companies to focus on fine tuning rather than building from scratch, which can save a lot of time. So compact design with this built-in reliability is critical as EV adoption grows and more manufacturers they want solutions that are both space saving and efficient.
That's really good to know that there's so much support to help these manufacturers build better onboard chargers. I'm just interested in maybe changing focus a bit. We've talked a lot about EVs, but obviously, particularly in cities, it's two-wheelers that are really driving a lot of the e-mobility. So, I mean, there's a huge range of two-wheeler vehicles. So, how are manufacturers coping with that? Because presumably, again, you've got a real scalability problem from a scooter to kind of an electric moped.
Yeah, scalability is one of the big challenge that company facing developing this kind of two-wheelers. From designing a motor control system that can easily scale up to high power e-motorcycles, right? Or scale down to the lighter e-bikes. And each type of these two-wheeler has different power, performance, and size requirements. So company often needs to create separate designs for different models. This would take a lot of time and resource, especially adjusting the components and software for different power levels. So reference design can really help to solve this problem by providing a flexible foundation that the company can adapt to different power range from like 350 watts for e-bike up to 10 kilowatts for e-motorcycle. With the motor control software library and complete hardware design files, these designs gives the company a head start. They don't need to reinvent each design from scratch, which save development time and effort. This way, companies can meet a range of needs faster, bringing reliable and scalable two-wheeler solution to market more efficiently.
And that's interesting. You're talking about, at the high end, quite high powers. I mean, one thing I have learned from some of the EVs is higher voltages enable you to drive higher powers more easily and more efficiently. So is that happening with two-wheelers? Are people moving to higher voltages? And is that difficult, or is that a relatively straightforward transition?
Yeah, high voltage systems are definitely on the rise, especially since they allow for more power and longer range, which is ideal for urban commuters. By managing high power output safely in a compact design like a two-wheeler can be very tricky. Company needs the high quality and test components that can handle the demand of high voltage system without causing overheating. This is where robust motor control and power management solution can come into play. At Microchip, we're focusing on delivering battery management system, motor control system that ensure reliable and safety in even a compact and high power applications. This solution helps the manufacturer overcome the challenge of the limited space while ensuring that the power is managed efficiently and safely.
That's good to hear, and I think, a lot of people in cities would be really pleased to hear they're not necessarily gonna be stuck in cars. The two-wheelers gives them another option, so I'm really excited about this. I mean, I think, from what you've said, one of the big problems with e-mobility is that it's not a single application, it's a mass range of diverse needs. I mean, just to sum up, can you just explain a little bit more about how Microchip is helping, people meet all this huge range of needs, but also within short design cycles and producing high reliability solutions?
Yeah. So in summary, Microchip, we can provide a complete suite of a solution across the entire e-mobility landscape, including, we discussed that before, EV charger, onboard charger, motor control, DC to DC converter, DC to AC converter, a two-wheeler, right? Our reference design and scalable framework gives the company really strong starting points, allowing them to get products to market faster without compromising on quality. And for our clients, having this structured solution is a game changer because of its shortened development cycles, which allow them to deliver more reliable products to the market faster.
This has been fascinating. Wayne, I really appreciate your time. I feel I've learned so much, but if people are listening and they want to find out more about Microchip and the world of e-mobility, where would be the best place for them to go and learn more?
Always go to microchip.com. We constantly update our solution on our website, or feel free to reach out to the Microchip sales team and our distribution network. They can be happy to help you guys.
That's amazing. Wayne, I really appreciate your time. Thank you so much for explaining why Microchip is e-mobility.
Thank you for having me again. Appreciate that.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.